record and share screen. And let's see. I'm gonna make this go like this. Okay. Oops. I was like, that's not my first slide. That's my 35th slide. Okay, there we go. Okay, so I'm going to be talking to you today about measurement invariance and model invariance, or what they might call predictive invariance. So before we start conducting research across demographic groups or cultural groups, it is fair to ask, do each of our scales, or does a scale in particular, actually operate fundamentally the same across those two groups? We call that measurement invariance. There are a bunch of ways to test measurement invariance. You can do it with IRT, but most people generally use confirmatory factor analysis. So that's what today's talk is going to focus on. It used to be you mostly saw formal measurement invariance analyses in the literature when somebody had developed a translation of a scale in a new language, because then the first question you might ask is, does this new translation, do these new items really function the same as the original items? So that's why I've bolded cultures and languages down here. But increasingly, as I'm trying to publish scales, reviewers are starting to ask for measurement invariance analyses across things like gender, age, race, to demonstrate that a scale is reasonably invariant in these ways that are tested, in hopes of just, avoiding biased scales. There's a separate kind of invariance, and that's predictive invariance. And that's really asking, does a scale predict comparably across different groups? So this is important if you're using SAT scores to evaluate people for acceptance into college, or GRE scores for acceptance into grad school. If it doesn't predict equivalently, even if it's measurement invariant, if it doesn't predict equivalently across groups, then it would be dangerous to use. In the kind of research we generally do in this department, this predictive invariance is really, does that function similarly in models or in nomological networks? So I'm going to try to touch on both of those. I'm going to try to show you the code you would use in Mplus to do that. And I want to give you a couple examples if we have time. I'm going to be basing most of this, I've based most of this on Vandenberg and Lance, which is about the most cited guidelines for testing measurement invariance. They reviewed and synthesized 14 articles that gave guidance on using confirmatory factor analysis to evaluate, and SEM to evaluate measurement invariance, and came up with a set of sort of 5 standard steps for measurement invariance and additional 3 steps for structural invariance. More recently, Vandeshoot published some straightforward and practical guidelines on how to test measurement invariance. They suggest a step that Vandenberg and Lance doesn't include, but it's really nice because they paired their paper with PDFs of Lizerl and Mplus code so that you can see exactly how to do it. And actually, for recent articles that I was working on, I also contacted Vandenberg and got him to send me his Mplus code for all of his steps. So the code that I'm going to be showing you today actually does work. I used it in several of my own articles, and it came straight from these 2 sources. Another researcher has done a ton of work in this area, and that's Millsap. He wrote a book. it kind of covers both IRT and confirmatory factor analysis approaches to evaluating measurement invariance. And Millsap is the one who actually does a lot more work on measurement invariance versus predictive invariance, and when you might expect to have both and how you can have one without the other. So we won't get into it as much as what Millsap has to say on the subject, but those are some of the things that those were some of the main things that I would point you toward if you want more information. And I will upload those first two with this in the HSDG thing on Blackboard. Okay, so what are the steps? So Vandenberg and Lance identify step 0 as testing, they call it an omnibus test, testing if the variance covariance matrix among your items between two groups is invariant, identical. They actually say that if you show in this step 0 that you have an invariant covariance matrix, you don't have to do any of the other steps of measurement invariance. At least in the journals I publish in, I've never seen anybody do this step 0 or try to say, because we did this step 0, we don't have to run those 4 models you're expecting us to run. But they actually cite 4 or 5 papers that all agree that that's sort of an omnibus test, and it's really, really good if you are able to show that those item-to-item covariance matrices are invariant. The step that you typically see is first testing configural invariance, then metric invariance, and I'm going to show you exactly what those are in just a second. Van de Schut includes this intermediate step. I'm calling it 2.5 in this lecture. They call it step 3, where they test intercept-only invariance. I had one reviewer at one journal for one paper love that I put that step in, and then 2 other reviewers at a different journal hate that I had that step in there and get really confused. So that's why I've sort of italicized it. I'm not actually going to show you the code for it because typically people don't do that step. But this step 2.5, and one thing I'm going to talk about at the very end, or actually the end of this sort of didactic portion, is if you don't get scalar invariance and you need to try and figure out, do I at least have partial invariance, then this step 2.5 that Van de Schut recommends is actually helpful. But what you typically see, if you see a series of steps, you see step 1 and step 2, configural and metric, and those are the ones by far almost everybody uses. Step 3, testing scalar invariance. This is a more stringent test, and it appears less frequently in the literature, and because of the assumptions that it makes. And step 4, full uniqueness invariance, is the most stringent test. Now, there are, beyond measurement invariance, there's also structure invariance, and that's sort of asking, do the subscales, so step 5 would be, do the subscales of your scale actually have the same variances across the 2 groups? Step 6 is, do the subscales correlate with each other the same across groups? And step 7 is, do they have equal means across groups? These steps are testing structural invariance. The way we're going to set up the model in the code that I'm showing you today, we will only be able to test step 6, do the factors correlate to the same degree, to test structural invariance. So what are these steps? So to test if the covariance matrix among the items is invariant, you create a multi-group model and you constrain that matrix. And that's basically, that's the only thing your model is doing. So this is the only time you're going to see the opening part of the code. So we say, we point it to our data file, we tell it what the variable names are. I have the item 1, 2, and 3 in blue, and item 4, 5, and 6 in green, because those are our two separate subscales in this example. If you have item level missing data, which to be honest, we almost always do, you should code that as a discrete value before making this data set for Mplus, and using this command, missing are all -999 or whatever value you used, then invokes full information maximum likelihood estimation to appropriately handle that missing data. I've put this in red. Grouping is, and then the name of the, I don't know why I called it mail ID. Oh, I called it mail ID because this is how they self-identify. So trans males would be a 1 on this as well. So this is the name of our grouping variable, and then we tell it in these parentheses what the two values are and give them labels. We tell it what our ID variable is in case we're going to save something. We tell it what variables the model is going to use. So this, other than this grouping variable, the rest of these lines should be pretty familiar for Mplus users. Then we just list the items names here. That is setting the unique variance for each item. Well, by listing item 1, 2, and 3, and then giving those parameters the labels 1, 2, 3. Since this is a multi-group model, by labeling the variances for these 3 items, 1, 2, and 3, we are constraining them to be identical across males and females. So we're doing the same with the variances of the next 3 items, and then we are constraining the covariances between these items to be identical as well. What we want from this step 0 is acceptable fit, and these are the fit indices we usually focus on. And again, this is sort of an omnibus test. Technically, if you actually find great fit with this, you don't really have to go any further, although reviewers and readers will probably want you to go further. Steps 1 through 6 that I'm going to take you through are a series of nested multi-group models, and they are confirmatory factor analyses. Now, when you take observed variables, these x1, x2, x3, which would be our items, and form latent variables, you have to set the scale of this latent variable. So what Mplus defaults to is this panel B, where the very first variable that is assigned to that latent variable, the path to it is set to 1, and the intercept for that item is set to 0. And by doing that, you then set the scale of this latent variable. So Mplus defaults to that, and for many analyses, that's perfectly fine. But since these paths and whether they are the same across groups are our question of interest, we'd rather not one of the paths, we would rather not force one of the paths to be a specific value. So another way to set the scale of this latent variable is to tell Mplus that this latent variable has a mean or intercept of 0 and a variance of 1. And that's what we're going to do here, so that these path coefficients, these item loadings, can freely vary. Okay, so to test configural invariance, this tests for weak factorial invariance, and basically we create latent variables, the same latent variables using the same subsets of items in both groups, but we allow everything else in those things, the strengths of those individual paths, the error terms for the items, the intercepts for the items, we allow that to all vary across groups. Now, Van de Schut says, well, you could test the same CFA in each of your groups separately and show you get good fit, and that's perfectly acceptable. I actually would prefer, and Vandershoot recommend, I'm sorry, Vandenberg recommends just keeping it all multi-group, because this first step one multi-group analysis is going to be your core model. And as you go to step 2, step 3, step 4, step 5, step 6, if you start with this multi-group, you're just adding new constraints to each model. So you're making an increasingly stringent test. And the way you can run a multi-group is adding this grouping is male and tell it what the things are, as I've already said. So to test configural invariance, we would pull in our data. We would say grouping is male, ID 0 equals females, 1 equals males. Then we would build our model. We'd say create scale 1 from these items, create scale 2 from these items. Notice I have an asterisk after item 1 and item 4, the first item in the list. That is disrupting Mplus' default to set that first path to 1. And instead, these 4 lines right here fix the scale. So these 2 lines fix the variance of those scales to 1. And these 2 lines fix the intercepts or the means of those 2 subscales to 0. Then they added in item 1 to item 6 in square brackets. That allows the item intercepts or the item means to vary. And we don't really need this last line, but it ensures that scale 1 is allowed to scale, the latent variable of scale 1 is allowed to correlate with the latent variable of scale 2. Now, I built this model having told it this is a multi-group analysis. And so it will, by default, apply that to the female group. Then I add, after all of this appears, I add in model males and I repeat all of that. What that does is it tells Mplus super explicitly, please recreate this model, but allow it to freely vary in males as well. What we want is acceptable fit. So we prefer a non-significant chi-squared, although my data sets are all way too big to ever get a non-significant chi-squared. We'd like a CFI above 0.9, but preferably above 0.95. Same with TLI. And we'd like an RMSEA less than 0.08. If we get that, it tells us we have the same basic fundamental factor structure. The same items belong on the same subscales, and that's a reasonable fit. Step 2, we then constrain the path coefficients to be identical across groups. We want each item to load on each factor to the same degree. So we use that same multi-group CFA model from the previous slide, but now we are constraining these paths to be identical for each of our factors. So there are, by the way, there are just many ways of constraining and specifying which things should be free and which things should be fixed. And across this code, they use different ways of constraining and making things fixed. So if it's a little confusing, just trust. I tried to make this as generic as possible so you could take this code and paste your own item names in and be able to run your own analyses. So here we have started this with a grouping is male, ID 0 equals females, 1 equals males. Just like we did in step 1, nothing changed about that. But now we put the model here and we put, we form the 2 latent factors, we fix their variances to 1 and means to 0. And then we let the item means freely vary across males and females. And since there's a model females down here and a model males down here, that means whatever occurs up here in the top portion is forced to be fixed between those 2 groups. Again, we would like that to show acceptable fit. But now in comparison to step 1, we want only small changes in CFI and in RMSEA. And so we want the CFI to only decrease by less than 0.01 and the RMSEA to only increase, I think one of these needs to be the opposite direction, but you get the idea, by no more than 0.015. You might wonder, that seems arbitrary. Where did these numbers come from? I've given you 2 citations, Chen and Chung and Rensvold. Both of these labs ran simulation studies, Monte Carlo studies, to try and identify appropriate cut scores to flag potential meaningful decreases in fit. So that's where these came from. And yeah, if you are able to show that you still have good fit and the CFI and the RMSEA didn't shift too extremely, you have demonstrated strong factorial invariance. Not only do the items load on the same factors, but they also load, they have the same strength of loadings between the 2 groups. So the items that load really strongly on a subscale load strongly in both groups. The items that load a little more weakly load weakly in the 2 groups, or however many groups. Okay, the next step, step 3, is scalar invariance. We're only on step 3, but when Vandenberg and Lance looked at 67 studies who had included measurement invariance analyses in their papers, only 22% of them did this step 3, scalar invariance. And I'm going to talk about why that is in just a second. Well, I can talk about it right now. What you're doing in step 3 is you're not just constraining the item loadings across the group, you are now also constraining the item intercepts across group, which effectively is the item means. Now, if I was looking at a measure like, I don't know, sexual desire across men and women, and I know there's a huge, robust gender difference on self-report scales of sexual desire, and that it's believed in the field to be a real difference, not just a different interpretation of items, and that's supported by IRT analyses, then it may not be appropriate to run scalar invariance because you're not going to get good fit. It's going to try to say there should be the same average level of responding on each item in both men and women, and that might not be the case at all. Does it make sense? But for many scales where there's not some massive average difference, it's worthwhile testing this. So you constrain the item loadings and the item intercepts. This shows strong measurement invariance. If you can demonstrate scalar invariance, then it is fair to ask, do separate groups of people within each of those populations differ from one another on your measure? So again, we would make it a multi-group analysis with this command line, and then to constrain both of those things, all we have to do is just write this basic model, and the default in Mplus will then constrain all of this to be the item loadings to be fixed and the item intercepts to be fixed across the 2 groups. And if you're able to demonstrate scalar invariance, then it really justifies scores being compared across groups. Finally, full uniqueness invariance. So, oh, and by the way, this is all, as you can see, we started with step 1, we introduced constraints in step 2, We introduced more constraints in step 3. We're introducing the maximum amount of constraints in step 4. If at any point you start failing to show invariance, it doesn't make sense to do the increasingly stringent test, because if you fail at step 3, you will also fail at step 4. So at step 4, you constrain the item loadings, the item intercepts. You also constrain the item errors. So you're saying the items are endorsed to the same degree, they load onto the factors to the same degree, and they have the same amount of measurement error or noise between the two groups. So that's strict. If you can demonstrate that, you have strict measurement invariance. And to do that, all we have to do is take that step 3 model and add in the item intercepts and give them their own labels. That then forces them to be fixed across the two groups. And if you're able to demonstrate this, you can say that your scales perform nearly identically across groups. The final model, I'm going to call it step 6 because going back, we are setting the subscale variances to 1, and we are setting the subscale means to 0. That's why we can't do step 5 or step 7, because we are setting the means and variances of these latent factors. But we can test if their correlations are essentially identical across the two groups. And so we do that by taking the step 4 model and adding in scale 1 with scale 2 and giving it a label. That forces it to be identical across the two groups. And again, we want only small changes in CFI and RMSEA and still excellent fit. And that would be a demonstration of one form of structural invariance. The associations among the subscales remain consistent. So I've just taken you through all of these steps. I'm going to take you through the code for step 0, 1, 2, 3, 4, and 6. But before I do that, I want to talk about the other form of invariance, and that's model invariance. So let's say now we have scores on 6 variables. 3 of them we've identified as predictors, 2 of them as mediators, 1 of them as an outcome. We're just we can pretend that this is at wave 1, wave 2, at wave 3, or we could just be honest and say this probably would be done in a cross-sectional data set. I'm saying it's full mediation, so I'm not letting the predictors directly predict the outcome. I'm having them do it in this stepwise manner, in this indirect manner. So step 1 for model invariance, we could test the model in each gender group separately. So the output regressed onto the outcome variable, regressed onto the 2 mediators, the mediator regressed onto the 3 predictors, mediator 2 regressed onto the 3 predictors, letting the mediators correlate with each other and letting the predictors correlate with each other. You don't really need these last 2 lines because Mplus will do that automatically, but it can't hurt to put it in. I like putting it in just to know, to remind myself what the full model would look like. But I would recommend even if you do this model in both males and females separately, I'd recommend doing an unconstrained multigroup. And then what we want is acceptable fit. And if we get acceptable fit, that means that the model generally accounts for the covariance in both groups. Doesn't mean that it's identical though. Some paths might be stronger or weaker. Then we constrain that multi-group. So we just give those substantive paths little ID names, and these don't have to be numeric. This could just as easily be M1 out, M2 out, or A, B, C, D, E. But we give each of those paths names, and by giving them names, we're constraining them to be identical across men and women. Again, we want good fit when we've constrained it, and we'd like the CFI and the RMSEA not to shift too much. And if we can do that, we can show that our path correlates coefficients are highly similar across these groups, which is kind of cool because we can show then that if you have a big enough sample and you build a model, you can then test to see, does that model hold true in men and women, in white and non-white, in older and younger respondents. You can examine the generalizability of your model. Okay, so before the last lecture portion of this that I want to do before I get into the demo is some cautions. There is some pushback on measurement invariance. David Funder wrote a blog post, Misgivings, some thoughts about measurement invariance. So the first, and these are just some of his complaints that Melissa summarized when we gave an earlier version of this talk last year. Thank you, Melissa Sturgeapple. So it's not, measurement invariance is not a dichotomous truth. Scales can be partially invariant, and it's worth knowing that. And if scales are partially invariant, if a majority of the items are actually invariant, then you probably still could compare scores across cultures. You could ask substantive questions. So sometimes people get into this yes or no mindset, and that does them a disservice. You really only need configural measurement invariance, just the items loading onto the same factors, to really run correlational analyses. If you don't have metric or scalar or full uniqueness, that's okay. Maybe the exact numbers, maybe there's some difference between those groups, but at least testing for configural, and usually if they test for configural, they also test for metric. But configural measurement invariance is probably enough for you to still run correlational analyses. David raised a concern that an extreme focus on measurement invariance could exaggerate cultural differences when a lot of the research out of the cross-cultural field has been starting to emphasize more similarities than differences. And he was also concerned that it shifts the focus off external validity. And what he means by that is, if maybe a measure doesn't have full uniqueness or even scalar invariance across two cultures, but if it fits into the nomological net the same way and predicts outcomes in people's lives in the same way, then it's still a valid scale and worth using. So if you just focus, and that kind of gets to predictive invariance. He didn't use that term, but that measurement, it's not all about having a perfectly invariant measure, because you also care about predictive invariance. And if people get too strung up on the need for perfect measurement invariance, that could discourage cross-cultural data collection. Van de Schut actually gives some, so I'm not going to go over all of this, but Van de Schut gives some tips on how you can try to establish partial measurement invariance, and that involves looking at steps 1, 2, and 2.5 really carefully to see, are there just 1 or 2 items that if you release the constraints, then you get good fit? and so that you know, maybe 8 out of 9 items or 8 out of 10 items on a scale show excellent scalar invariance, but just 1 or 2 items need to have some of these things released to obtain reasonable fit. Okay, so that's measurement and model invariance overall. I'm going to give the example. I'm going to go through this example quickly. Again, I'll post these on the on Blackboard for everybody, as well as the video of this lecture. So with Yiying Lin, a student from Warner, and her advisor, I did a cross-cultural study. We took data from 688 white Americans, 319 Asian Americans, 332 people from basically Beijing, 400 people from Japan, and 362 from Taiwan. I had created this multidimensional psychological flexibility inventory. It's a 60 item, 12 subscale measure. We translated it into simplified Mandarin, traditional Mandarin, and Japanese, and published this paper validating that scale. And one of the things we did to validate that scale was to test the measurement invariance of the MPFI across these cultural groups, these 5 cultural groups. This was the model. I didn't put the item text in because you wouldn't be able to read it anyway. But it's 12 correlated factors with 5 items on each factor. And we were able to show, so this is the multiple group with no constraints, testing configural invariance. And you can see it has reasonable CFI and RMSEAs and TLIs. Then we actually showed it tested in each of the individual groups separately. Then we added in the metric invariance constraints, forcing the pattern factor loadings to be identical, and only got a slight shift. Still good fit. We tested scalar invariant. I'm sorry. We did the extra step of Van de Schut and tested the invariance of the intercepts of each item. And then we did scalar invariance and full uniqueness invariance. And we were able to show the measure was reasonably invariant. So this is talking readers through all of those steps in a really super clear, taking a lot of journal space kind of way. So we explained how we set up the model. We explained our parameterization. I explained what configural invariance was, and said since it showed good fit, this indicates that the CFA model is valid in each of the groups, suggesting a common factor structure across all 5 groups and all 4 language versions of the MPFI. When the factor loadings in the model were constrained to be equal across the 5 culture groups, it continued to demonstrate fit. And Van de Schut's recommendation is to say this means the respondents attributed the same meaning to the latent dimensions. The intercept only just means that the levels of the underlying items remained roughly equivalent. And this is text directly out of the paper, and that will be in the Blackboard as well. Scalar invariance supports scores being directly compared across groups. And full uniqueness invariance suggests the constructs are essentially measured identically across the 5 groups in 4 languages. And so it's kind of a minor miracle that across these 5 cultural groups and 4 languages, we got full uniqueness measurement invariance. We're so happy. I mean, we did put a lot of effort into creating the scale originally and into the translations, but this was really a wonderful finding when we got it. So that's an example of showing the results to readers and explaining them in a way that's really clear step by step. Jen Dax and I just got a paper accepted by Mindfulness, the journal. And in that we have 2,742 online respondents, primarily from the United States. We gave them the 60 items of the MPFI, and we also gave them the full FFMQ, but we identified the 10, there are basically 2 dimensions in the FFMQ that are not redundant with 12 dimensions of the MPFI: observing and describing, observing sensations and describing feelings and emotions. So we used IRT to select the best items for that and created a 70 item, 14 dimensional unified flexibility and mindfulness scale. In an effort to test the unified flexibility and mindfulness model. And I will actually show you that model right now. So we actually, what we found, this was prompted because the mindfulness literature identified a bunch of dimensions of mindfulness. The ACT literature identified a bunch of dimensions of flexibility and inflexibility. And when you looked at the scales, many of those dimensions were overlapping. And we feel that in alignment with Buddhist texts, all 14 of these dimensions, or all 14 of the blue, green, and yellow dimensions are aspects of mindfulness. So the blue are filters or lenses that we use to filter in or out input from the outside world. So being able to describe your feelings, observe moments, being attentive and aware, or inattentive and distracted. And we thought those things are so fundamental. So this is how you would notice and detect if you were upset or if something unpleasant was going on. And so we thought these would influence all of the stages in the model. They could have links to well-being and distress directly. They could shape life-enriching, value-driven behavior directly, and they could also influence these flexible responses to difficult feelings. There's a lot of dimensions in these 6. What Buddhism would call this is decentering. So if something unpleasant or disruptive or negative or upsetting or challenging happens, how much are you able to approach it with an air of acceptance and tolerance and compassion, maintain a broader perspective in the midst of those negative feelings, gently experiencing with it without getting sucked into it or clinging to it? Or do you avoid it? Do you shame or judge yourself, or do you get stuck in those feelings? So this is obviously overlaps a bit with the emotion regulation literature, and your ability to sort of decenter from those difficult experiences can then allow you to take steps toward the deeper goals in your life, even in the midst of stress, chaos, and setbacks. So maintaining contact with your deeper values and continuing to take steps toward goals, even when life kicks you in the shins or gets you down. And then these value-driven behaviors would drive individual functioning, global functioning. So we tested that model, and I'll show you the model results, but actually, we initially, since we had a sample of 2,700 people, we did a random sample split, and we ran the model in both sample halves and got shockingly similar results. No particular surprise, and so we essentially cross-replicated our own findings, which is great. But the reviewers actually encourage us to go a step further and run a multi-group unconstrained model, and then constrain it to be equivalent across groups, constrain all of those predictive paths to be equivalent. And when we did that, Well, they also encouraged us to see, does the model remain the same? Can you constrain it to be identical across age groups, across self-identified gender, across levels of meditation practice, and across recruitment sources? So when we did that, the first thing you'll notice is that analyses in each subset, as well as the multi-group unconstrained, gave excellent fit, really truly outstanding fit as far as the RMSEA goes, the CFI, the TLI, and the SRMR. But the other cool thing is that the CFI and the RMSEA did not change that much in response when we constrained it. So not only did we still get good fit, but really there were only a couple points where our model failed to give, where the CFI increased a little, and unfortunately across recruitment sources, both the CFI and the RMSEA changed quite a bit. But generally, these results suggested that our model was consistent across genders, across ages, across meditation groups, and were replicated in 2 random sample halves. So when we showed the model to readers, we actually showed the coefficients that emerged in both random sample halves to show that it was replicated. And we found that indeed these lenses that made you attentive and aware helped predict using a broader perspective and gently experiencing feelings, which helped predict taking steps towards your goals and maintaining contact with values, which promoted life satisfaction. And being inattentive and unaware helped promote judging your feelings and getting stuck in them, which left you stuck in inaction, which promoted depressive symptoms and lower life satisfaction. So that was really cool. And I was so happy that the reviewers encouraged us to look at model invariance, because it was something that I had never done before. But essentially, we were able to show, yeah, not only do we have a model that cross-replicated across 2 random sample halves, but it remained fairly robust and consistent across age groups, gender, meditation practice. Because that model was supportive, again, obviously these are cross-sectional findings, although now, thankfully, we have longitudinal findings to come back and look at this. But those are cross-sectional findings. But to facilitate future research, we used IRT on the describing and observing FFMQ subscales so that we could add 2 subscales to the MPFI to create the UFM scale. And the first thing we wanted to know was, did we get measurement invariance? So this is us testing configural, metric, scalar, full uniqueness, and factor covariance invariance across gender identities, age groups, and meditation practice. And much like we got in the cross-cultural data, in this data, we got excellent CFI, TLI, SRMR, and RMSEA fit for all of these models, even the full uniqueness invariance, which is awesome, and even the factor covariance, which is a step farther than most people go. And generally, the RMSEA and CFI did not increase excessive amounts or shift excessive amounts to show like a fit. So we were able to add the following to the paper. This is obviously a much shorter. In the previous paper, because it was the validation of a translation, we explained configural, metric, scalar, full uniqueness, and structural invariance one by one. In this data set, we didn't. In this paper, we didn't. We just said we tested all of those across gender, age, and levels of meditation. We talked about the fit in this next sentence and mentioned that we also had structural invariance. The subscales correlated with one another in highly similar manner across those groups. Thus, the UFM scale demonstrated robust measurement and structural invariance, supporting the direct comparison of scores across these groups. So that is all I wanted to cover. These are the references. So Chen and Chung are the amount of shift on the CFI and RMSEA that's acceptable. These two are the examples from my own published papers, and Vandenberg and Van de Schut are the articles giving concrete guidelines. So does anybody have any questions?
Thanks, Ron. That was really great, and great to see each of the steps walked through. I had kind of a broader question about the steps before measurement invariance. Did you have any advice for researchers to be mindful of on what they can do to maximize the likelihood that their scales will be invariant once they get to that stage?
Well, yes. There are no easy answers, right? Are you I can tell you when we made the MPFI, for example, I'm not surprised that the MPFI and the resulting UFM scale, which is 70 items in 14 dimensions, was invariant across gender, for example, because when I make a scale, I usually run, like in my initial, like I'll collect sort of pilot data or early, like the first 1,000 responses, I'll just run crap tons of EFAs in it to find pools of items that seem to be measuring the same construct. Does it make sense? And when I run those, I mean, really, you only need like 300 people, maybe 400 people to get a really stable EFA finding. But I'll make sure that I have at least 300 or 400 men, so that I can run EFAs in men and women, and I'll take the items that show consistent factor loadings across men and women for my pools to submit to IRT. Does it make sense? So that from the and that's possible if you start with large pools of items and you collect larger samples so that you can run male and female analyses, or whatever the group. I mean, I'm a couples researcher, so male and female is a pretty important group for me to make sure it works similarly across. But so that I can run EFA analyses and just identify pools of items that already, in an exploratory kind of way, seem to have similar structures across those groups. Then I'll submit those, then with each of those little pools of, however many, 15 to 45 items, I'll submit it to IRT. And when you're running IRT and to select the most effective items, when you're running IRT analyses, one thing you can do to sort of test your model fit or the stability of your solution is to run subgroup analyses. So whenever I run IRT analyses, IRT analyses tend to start stabilizing around 400 or 500 subjects. And certainly by 800 or 900, they seem to be pretty stable, at least in my experience, with the kind of items that I've been looking at. But I'll collect 2,000 people to run IRT analyses on, so that I can run IRT analyses in men and women separately. And then I'll make graphs of the item parameters as estimated in men and as estimated in women. And what you expect to see, I hope I'm not going into way too much detail. I apologize if I am. Whoops. So what you expect to see is pretty much a one-to-one correspondence. And if you're familiar with IRT, what I'm showing you a graph of is sort of the beta parameters, which are sort of the thresholds between that are the boundaries between selecting one response and the next highest response. And you want it to be one-to-one. And what can happen is maybe an individual item will have a beta here, a beta here, a beta here, and a beta here.
Ron, do you mean to be sharing your screen?
Oh my gosh, can you not see this? Oh, I stopped sharing my screen. Yeah, hold on. Yeah. Yes, I totally do. Thank you. Let me see. I want to get out of this. And where is that? Here. There we go. Actually, I'll just redraw that really quick. So if we're doing a scatter plot where we plot for each item's parameter, we plot how it was estimated in men and how it was estimated in women. We want kind of a one-to-one correspondence. At the extremes, we expect it to fan out a bit because there are really few people out here driving those estimates. But we expect a one-to-one correspondence. And when you do that, what then can happen is for maybe an individual item, you'll see, well, for this question, its item parameters were way off the diagonal. Men read that item very differently than women did. Does that make sense? Where all of the other items are pretty much a one-to-one correspondence, this item's parameters are very, very, very different. So when, in answer to your question, Bonnie, in addition to running EFAs in men and women or in any demographic group where I'm worried about wanting invariance, I make sure my EFA step, I'm running men and women analyses. Oh, that's what I want. And then also in IRT, I'm running male and female analyses and screening out items that function different in the two groups. So that my final scale, when JC and I spent 2 years making that MPFI scale, it took us 2 years because we started with 500 items and we did all of that labor-intensive EFA and IRT screening to get not just the items that worked the most well, but that seemed to work consistently across groups. And I think it was running those extra analyses that allowed those allowed that measure invariance to work so well in that paper that Jen and I just published. It was lucky. I don't know, as far as validating a translation in a new language, the only thing you can do is try to avoid slang or ideographic expressions, right? Try to state your items really simply without drawing upon cultural references or metaphors, because those are the kinds of things that translate terribly across cultures. And a word-for-word translation is not going to function well in a new language if your items use a lot of that. But if you want to measure relationship satisfaction and you say, how rewarding was your relationship? How satisfied were you with your relationship? How much do you feel like a part of a team with your partner? Those items are so straightforward that even a direct translation into Italian or French or Mandarin is more likely to work and to be reasonably invariant. But if you say, well, it's hard off the top of my head. I can't think of an item that would be culturally biased off the top of my head because I try to avoid those in general. But does that help, Bonnie?
Yeah, that's super helpful to think about looking at these groups separately even before measurement invariance.
Yeah,
I
when you're
ask because
oh, go ahead, go ahead.
oh yeah, I was just saying, I asked because I saw at least one instance of a researcher doing a lot of work for a scale, and then they got to measurement invariance and saw that it was not invariant, and they had all this data and all this work. So it's helpful to hear those tips on what you could do before you get to that stage to avoid headaches once you get to measurement
Yeah,
invariance.
well, and with we are now, Ying and I also included about 130 items asking about tenets associated with Buddhism, Confucianism, and Taoism. And we are trying to publish that scale. And with that scale, with those items assessing different ideologies like Zerang and Wu Wen, we got partial measurement invariance. We were able to get scalar invariance by releasing maybe 8 or 9 items, the constraints, releasing 1 or 2 constraints for 8 or 9 items out of a 60 item scale. So the vast majority of the items were scalar invariant, and actually we got halfway decent full uniqueness invariance. But there, on each subscale, there were like 1 or 2 items, really 0, 1 or 2 items that didn't really meet that. But hopefully the reviewers will let us call that partial invariance. And I think it still makes for a useful scale. It's just you need to be a little more cautious about interpreting mean differences that way.
Thanks, Ron.
Any other questions, thoughts, concerns?
I have this isn't really a question because I don't think there's an answer to it, but how do you deal with reviewers who want you to demonstrate invariance when your hypothesis is that these subfactors will relate differently in different cultures?
Right. Well, most people, so if you're talking about the subfactors, like the correlations between your subscales, then most reviewers don't make you test that structural invariance, do that last model. But Harry, I think that's an awesome question. And I was kind of anticipating that question and another question, like what if, and I've kind of already answered the other question, like, the third step is scalar invariance, but you're not going to get good fit for scalar invariance if there's a huge difference in endorsement between groups on your items. And there's no, I guess reviewers just let people argue it does. And this wouldn't, this could be a male-female difference, or for clinical scales, I would anticipate that the item level endorsement is going to be very different for non-clinical and clinical samples, like by definition, if it's an outcome measure.
Right,
So
but see, then what we got hit with was the reviewers saying, how do you know that the constructs relate differently in the two groups, or the measurement is just not appropriate in the two groups?
Well, you could rely, what I would do off the top of my head, and we can talk about this more, but off the top of my head, if the items are still internally consistent in both populations, in both subsamples, that's at least saying the scale is, that the scale is still, the items still appropriately correlate with one another. If you have configural invariance, that's even better. And if you have metric invariance but not scalar, I think the current standard is if you are able to show configural and metric, then you can say we don't anticipate scalar or structural, and that the metric and configural are all you need for correlational analyses. I think that I'm not sharing screen, but what I'm doing is I'm pulling up that caution.
Well, that was the funder point, was saying that you only needed configural.
Right. He might even in that blog give a citation for only needing configural. So you could give that citation to counter the reviewers.
That would help.
Yeah. But I think having configural and metric and internal consistency, you could argue the scale's functioning well. We just anticipate these differences. In fact, you could argue that the differences you're observing are criterion validity.
Good.
Does that make sense?
Yeah.
But that's that's when you anticipate, well, and so your question is also basically your groups are moderators, right?
Yeah, the whole purpose of the research was to show that they were different.
Yeah, so your groups are moderators, just like if you have a group difference, you're not going to get scalar. If your groups are moderating those effects, of course you're not going to get structural. It doesn't mean that you don't have measurement invariance.
Yeah,
So
well, in the regression analysis, they're massive group effects.
Wow, that's super
Massive
cool.
interactions involving groups. So
Yeah.
there's a ton of moderate. I mean, there are Fs in the hundreds.
Wow. So if you can show even a little bit like configural and maybe metric, then that would be and then give that citation that.
Yeah, see, we weren't smart enough to do all the steps you described in answering Bonnie's questions. And so we were kind of stuck with, well, we collected all these data, so let's cross our fingers.
Well, and you can also
configural was okay, but we didn't get metric.
Oh, you didn't get metric?
Oh,
How far was metric? Pretty far off?
Yeah.
Okay.
It wasn't close. I mean, releasing a few paths wouldn't have made a difference.
Fair enough. So it would be trying to track down that citation suggesting that configural is enough for correlational analyses.
Yeah, well, I'll ask David.
Yeah.
Thank you.
That's what I would do. So yeah, the more measure development I do, the generally the larger the item pools I start with to try and stave off problems like this down the road. There was a time when we have a sex positivity and negativity scale under review at Archives of Sexual Behavior that I did with an undergrad. And we hadn't done invariance analyses, but we made like a 4, 8, and 2, or I can't remember, 12, 8, and 4 item versions of the scales. I can't remember. We ran generalizability analyses. We split our sample up into a whole bunch of different demographic subgroups, and then just ran Cronbach's alphas in each of our subscales to make sure they were still internally consistent. And oddly, one of our 4 item scales had lower internal consistency among gay and lesbian respondents. It was actually specifically gay men. It had lower internal consistency. But there was another item that we could easily include on the 4 item scale instead of the 4th one we chose that had good internal consistency. I'm sure that decision and putting that on that 4 item scale helped increase the measurement invariance. Does that make any sense? But it was sort of a far simple, well, I don't know, it was labor intensive in its own way, but it was asking the same question: are these items hanging together to the same degree in each?
What you're really saying is that the way to get measure invariance is to develop your scales to get measure invariance.
Yeah. If measure invariance is important to you. Now there are some things, so there was, and if you guys can drop out if this is boring or whatever, but I'm happy going a little longer if you're interested. I'm going to do that drawing thing again. There was, when we were making a measure of sexual satisfaction, most of the items, Most of the items were measure invariant. Showed no differential item functioning. But the items that were asking about, I wish my partner wanted more sex, or I wish my partner didn't want so much sex, like a difference in sex drives, there was a huge, like those items all came out here. And there was a clear, almost one standard deviation shift between men and women consistently on all of those items. They actually formed a separate factor in the EFAs. And so they were sort of contaminating items on some of the previous measures of sexual satisfaction. So we just avoided them. But if we had been making a measure of sexual desire, sex drive, I would anticipate that what would happen is, even with IRT, if we had a pool of 100 items, every single item in the pool would be shifted. Like there'd be no way to find an unbiased item because it's not actually bias, it's a real gender difference. Does that make sense? Mm-hmm. And in that case, if you're making a scale like that, then it's, that's not really bias. That is a true difference that you just have to embrace. And you're never going to get scalar invariance between men and women because there's just too huge of a true gender difference. Does that make sense? Mm-hmm. So there are definitely limitations. And the good news is it means that if you don't think running scalar invariance and full uniqueness invariance, the assumptions with those models aren't appropriate because you anticipate a difference between groups, then you can justify that and you don't have to run them. And plenty of papers, like only 22% of the 67 papers that Vandenberg and Lance reviewed in 2000 had included scalar invariance. Most of them just did, I'm sorry, I've been configural and metric. It was like the C one, configural and metric. So, and if you're expecting that specific group to moderate, then you're definitely not going to get structural invariance because that's your moderation. So you just have to be clear about those expectations in advance. That will make it seem like less sketchy. Does it make sense? Mm-hmm. And justify them, and then reviewers should accommodate that. You can also cite you can cite Vandenberg and Lance because they talk about if you have a group difference or if you're anticipating these groups moderating, then these models don't make sense to test. Mm-hmm. Yep. If that helps. So that was the review process was unnecessarily painful getting my first two papers into the journal Mindfulness, but I loved those reviewer suggestions to test the invariance of my model, of the paths in my model. That was really cool. And then to find that it was invariant across all of those different groups, that was awesome. It was a ton of extra work, but it definitely enhanced the quality of that manuscript. Any other thoughts or questions? Okay, so I think we have, I will double check, but I think we have someone, Aliza, is it you? Aliza is going to be giving it in December, and I'll probably maybe over Thanksgiving, I'll send out a doodle poll with dates in the new year in the spring semester. Do you think we should have one in January since classes like toward the end of January, or no, Harry?
I would say no, unless we have more people that we need to accommodate in the spring semester.
Fair
So
enough.
if we have more than 3 people who want to do something, then we should, but otherwise.
So
you
we
know,
have February, March, and April,
right.
and we could probably do a May. Maybe I'll send out an email and ask the grad students, are any of you hoping to do one this year? And that'll give us a sense. Because we could always do one near the end of January, for example, and it would probably be okay.
Mhm.
Okay, well,
Thank you.
have a great week.
Thanks, Ron.
Thank you, Ron.